Woo, more data and statistics. All right, so today we are moving on from yesterday's lesson on stem and leaf plots to our next data display, which is histograms. So let's go right there. I'm first going to show you a visual of what a histogram looks like as an example. This is an example of a histogram. You can see that this data display is capturing the number of instruments played by people in a band, we'll say in a jazz band. I was in a jazz band. Um, and we can see from this data display a couple of things. Let's see. I can see that people played some range of instruments, like people played either one or two, three or four, five or six, seven or eight instruments. Looks like most people played one to two instruments. Okay, so if that's what a histogram is, let's get some notes down. First off, a histogram is a type of bar graph. Um, we can clearly see that it looks like a bar graph. It's a type of bar graph, and each of the bars in the bar graph is an interval. It's a range of numbers. Like the first bar in this graph is an interval of 1 to 2 instruments. The second bar is an interval of 3 to 4 instruments. The next bar, although it's no one, would be 5 to 6, and the next bar is 7 to 8. So each bar in this type of bar graph is an interval, and the height of each of these bars represents, and I'm going to use a big word, the frequency, aka the amount of times something in that interval happens. So the amount of times that there is a person who plays one to two instruments in this band occurs 6 times. That's its frequency. The frequency of a person playing 3 or 4 instruments is 3. The frequency of someone playing 5 or 6 instruments is non-existent. That does not have anything happening there. And the frequency of someone playing 7 to 8 instruments in this particular example is 1 person. But yeah, that is the very basics of what a histogram is. A type of bar graph. Each bar in the graph shows an interval of something happening, and we know how many times that happens, the frequency of that happening, by the height of the bar. Here's another example of a histogram. This one shows the height of trees. And we can see that the first, it might be a little challenging to see, especially if this is your first time looking at histograms. The first interval is from 100 to 150 centimeters. That's the first. The next is 150 to 200, 200 to 250, 250 to 300, and then 300 to 350. We can see that most trees in this study were between 250 and 300 centimeters high. There were not a lot of short trees. Yeah, so those are 2 examples of histograms, and now we're going to get a little more detailed in what we're doing. The 2 things, just like yesterday, that we are going to accomplish are, number 1, can you create a histogram from scratch? And then number 2, can you interpret what's happening from a histogram? So let's get into that. First is creating a histogram. The first thing I'm going to do is I'm actually going to go over a few important reminders. If you're a note taker, these are definitely things that you'd want to jot down. These are key features of a histogram that you should keep in mind when creating your own. Number 1, when you create a histogram, you're going to have an X and a Y axis. Remember, the Y axis is the one that runs up and down, and the X axis runs left to right. The frequency, aka the amount of times that something is happening, is always going to be captured on the y-axis, whereas your intervals are always going to be on the x-axis. So although our histograms might not look exactly identical, this is one of the things that should be true. The amount of times something happens, how high the bar is, that should always be happening on the y-axis, and the interval is always on the x. Speaking of the intervals, the intervals should all be the same. You'll note that if we went back to the examples from before, these were all, in the instruments played example, these were all 1 to 2, 3 to 4, 5 to 6, 7 to 8. They were all too long or too big. Like the interval ranged from two numbers. Down in this tree height example, all of the intervals were about 50 in length, 1 to 150, 150 to 200, 200 to 250, 250 to 300, etc. So your intervals should all be the same. You shouldn't have one interval that is bigger than the other or one that is smaller than the other. They should all be the same range. This one I'd put a little star by, and it's going to sound a little weird at first, but there's a reason for it. Your bars, when you create the bars in the bar graph portion of this, should all be the same size, not the same height, but the same width. And they should be touching. There should be no spaces in between them. And there's a reason for that. Histograms are meant to show the continuous flow of data. And you have to think about how people are looking at the histogram. When you are looking at it, one of the things that is going to help you see that the data is continuous is the fact that there is no space in between the bars. They are all touching. And the other thing is you want them all to be the same width approximately, because if one is bigger than the other, like if it's a little thicker than the other ones, that's it's going to make it jump out, and it shouldn't. They're all the same interval. The intervals are not bigger or smaller than another. So to reflect that visually, we want the bars to be the same width. That will show us that the intervals are all the same, and they should be touching to show that the data is one continuous flow of data, 100 to 150, 150 to 200, 200 to 250. There's no breaks in the data. So those are visual touches that you can put onto your display to help reinforce those facts. And the last thing is, don't forget to label your X and your Y axis. And make sure you give your display a title. Let's go back to these examples real quick. Both of them have an X and a Y axis labeled, and they both have a title so that we know what exactly we are referring to. You want your person reading your data display to know what's going on. You don't want to have them search for more information. It should all be right there. So without further ado, let's create ourselves a histogram. I'm going to base this creation off of a little example that I made up. A coffee shop is trying to make a more accurate order of espresso beans. If you own a business, you have to order product. And so to do that, one of the things they do is they start tracking the number of cappuccinos that are made every hour. What I did was I recorded that data for you, and I put it in order from least to greatest. It won't obviously be like that for you, but I'm helping you out. So in one of the hours, for example, they made 11 cappuccinos. In one of the hours, it was super busy. They made 18. And then maybe there was a little lull in the middle of the day. They made 0 cappuccinos, but this is the tracking of how many cappuccinos were made per hour at this particular store. So I'm a steps person. Let's break this into steps. Step 1, you want to take this data and you want to organize it into something that I call, or is called, a frequency table. A frequency table keeps track of how many times something occurs. Now, I already created a frequency table. You don't have to make it look as pretty as this. It can be something that's a little bit of a rough sketch. But what are we keeping track of? So my first column, we're keeping track of the number of cappuccinos that are made per hour. Now, the first thing we want to do is we want to break the data into equal intervals. I noticed that this data ranges from 0 to 18. You don't want to have intervals that are super big. You also don't want to have them that are super small. So what I'm going to do is, since 18 is a multiple of 3, I'm going to do everything as a multiple of 3. All of those intervals range in, actually those are intervals of 4 if you're counting every number. So the first is 0, 1, 2, 3. That's 4 numbers. The next is 4, 5, 6, and 7. 4 numbers. 8, 9, 10, 11, etc. They are all equal. Now, I put 2 columns to the right here. One says tally, and once is frequency, it is totally up to you which one you want to use. Some people like keeping track with tally marks, like uh, how many are in the 0 to 3 range. There are these two, so 1, 2. Some people would rather just straight up write the number 2. It's up to you which one you want to do, but I'm going to fill in this table. There are 3 in this range. There are 8 in this range. You can double check me if you want. There's 3 in this range, and there are 2 in the last. So now I have everything I need to create my histogram. I have my intervals that I'm going to use. I have the frequency, aka how tall each bar is going to be. So let's go ahead and create an actual histogram. You might not have graph paper at home. I'm not going to use graph paper either to show you that it is super doable without those things. First, my x and my y axis. Okay, this looks a little bit neater than my handwriting would have been. I got my X and Y axis labeled, I have my title, and now we're ready for the final step. The final step is to draw a bar to represent the frequency for each interval. So if you can remember my first interval, I'll scroll up real quick, was 0 to 3. So let's capture that. We're going to make sure that the bars are approximately the same size and that they are all touching to show that the data is one continuous flow. So my first bar, and just by the way, I'm going to be counting by 2s here. So every line on the left, on the y-axis, is 2, a unit of 2. So the first bar is going to go, and that is 0 to 3. My next bar is going to be 3 units high, so that's in between 2 and 4. And that's 4 to 7. My next bar is 8 units high. It's going to be the tallest bar, actually. And that's 8 to 11. My next bar is 3 units high again. Oh, look at this beautiful, perfectly equal data display. And then the last one is going to be 2. Ooh. All right, and that's 16 to 19 cappuccinos made per hour. And there we have it. We've made a histogram. So a histogram is a type of bar graph. It captures the frequency of something happening through intervals. Yeah, very nice. We've made one. You can make one yourself too. Last thing for today is interpreting a histogram. So for this last example, I have a histogram that shows the winning speeds at the Daytona 500, which is a NASCAR race. The bottom axis, the x-axis, represents the intervals of speeds. So I'll give you a little bit. It's the first interval is, it looks like there was maybe 1 or 2 cars that had a winning speed somewhere in the range of 120 to 129 miles per hour. There were 8 cars that had a winning speed somewhere between 130 and 139 miles per hour, and so on and so forth. I think you can interpret that from there. So the first question says, which interval contains the most data values? That is not a difficult question to ask. That would be the interval of 150 to 159. And how do I know that? In an instant, it's the tallest bar. That'd be this one right here. So it has to have the most data values in there. How many data values are in there? This bar looks to be just over 20, so I'm going to say it's probably 21. Cars had a winning speed in there. And there you go. Our second question says, how many of the winning speeds are less than 140 miles per hour? Well, that means it can't be 1, 2, 3, 4. It can't be these last 4 bars because it says less than 140. And all of these speeds are 140 or greater. So it's going to be this bar, which has 8 in it, and this bar, which has, I'm going to say 1 in it. So how many winning speeds are less than 140? It looks like there are 9 in that range. 9 cars, I guess I'll put, or 9 speeds. And then the last question says, how many of the winning speeds are at least 160 miles per hour? At least means it can include 160. So that would be everything in this second to last bar and this last bar, which is going to be 8 plus another 4. So I'm going to say in total that is 12. 12 speeds. I'm going to also ask you a question that's not on the screen. How many cars had a speed of 142 miles per hour? I'll ask that again. How many cars had a winning speed of 142 miles per hour? And the answer is you can't answer that. One of the hindrances or the detractors for using a histogram is it does not show specifics for data. It does show us a lot of information, but it doesn't give us specific data values. I don't know if any cars drove 142 miles per hour, or maybe every car in that third bar, 140 to 149, maybe all of them are 142 miles per hour. We don't know. We know that there are some cars in a range of the 140 mile to 149 mile per hours, but I don't know actual specifics. So one thing that kind of takes away from histograms is if you want specific data values, this is not the type of display for you. You cannot get specifics from this. This gives us ranges, it gives us intervals, it gives us frequencies for those intervals, but it does not give us specifics. Histograms are great to use when you have a lot of data because I don't have to put every single data point on there. I can rather capture things within a range. But it has its limitations, so you have to know when it would make sense for you to use. Otherwise, good luck today on your work. If you have questions, reach out. And that's it. See ya.